Alrighty, welcome. We are in Chapter 2 of Science of Flight, Lesson 4, Weather Forecasting. Of course, we live in Arizona, but weather forecasting is a rather important part of our lifestyle. I'll tell you what, just like on pages 168, 169, what are they talking about there on those pages? A historical importance of weather forecasting, guys.
D-Day. D-Day, sir.
D-Day. When was D-Day?
The 6th of June on 1944.
1944.
1944. Who was the Allied Supreme Commander?
Dwight.
General Dwight Eisenhower.
Great. Dwight Eisenhower. And you know, like great wars, a lot of times come down to the decisions of one person that can affect the war or the actions of one person. General Eisenhower had the decision to make as far as when they were going to invade Normandy, the beaches of Normandy. So you're going to invade these beaches of Normandy. Some of them had cliffs, most of them had cliffs. And what kind of considerations would you have to do in order to invade a country? Yes, sir.
Taking like civilians and kids.
How are you going to get them on the beaches? I mean, how are you going to invade on boats? Well, then boats are floating on what? And so when you float boats on water, is it good to have a lot of water or a little water?
A lot of water.
So what gives you a lot of water?
High tide.
High tide, that's exactly right. So really, if you're the Allied commander, do you want to go in at low tide?
No.
You want to go in at high tide, which has to do with what affects your tide, what makes your tides high or low. There you go. So if you looked at the article they were talking about, the high tides were only, between June 5th and 7th and June 19th. And of course, this is all very, very secret, right? They actually had a diversion. We covered this in our last class, actually. A diversion tactics, and the Germans thought they were going to be invading in a different part of the channel. So everything was top secret. So if you delay it 1 week, they may find out. And so he had a pretty hardcore decision, General Eisenhower, as to when to invade. When does he say go? My dad was in that invasion, not the first day, but the first week. And he was sitting in England. Everybody was ginned up, everybody was loaded up, and all they did was wait. And they just sat there and waited. And everybody's ready to go, and they go, no, wait another day. So they sat there and played cards, and back then everybody smoked cigarettes, and they ate. And they said, okay, tomorrow? No, wait. And all they did was wait. And when you're an army guy and you got 2 million people there, and all you do is wait. That's kind of bad for morale, right? And if you actually watch some of the movies about this, even in the movies, the weather forecaster was the one person that Dwight Eisenhower relied on, other than a chaplain. Honestly, there was a lot of praying going on, because you have over 1 million people getting ready to go and invade the cliffs of Normandy against the most fearsome German army, and the commander goes, wait. That's kind of tough. And so it came down, as this article talks about, British and American forecasters, and you could argue that this was the most important aviation forecast, weather forecast of all time. And guess what? On the first day, they were trying to do it on the 5th of June, because again, just even delaying it 1 day could foil the surprise. They chose not to do it on the 5th, and then God or weather or the high and low pressure systems or whatever gave them a break in the weather on the 6th of June. Why do you need a break of weather just to drive a boat across 20 miles and invade?
Because it's really wavy.
Wavy, yes. What else? You're right, but you're going to invade. These cliffs of Normandy have these huge guns up there. What can you do to help yourself if you're going against huge guns?
Bombers.
Bombers, yes, exactly. And also, you don't realize, but during the invasion of Normandy, they all didn't come over on boats. They came over on gliders, one-way planes. So you would take off in planes, and they have parachuters, and they chop off the glider, and the glider would come down and land in a field, and everybody jump out behind the lines and attack the guns from the backside, or take the bridges. So that not everybody going across the beaches of Normandy were in a boat. And so you had to have good weather for the planes. and it were one-way trips, obviously. And so I'm telling you, again, you can, if you're spiritual, you can call it divine intervention, or you can call it luck, or the weather. But this one forecast changed the course of the world. We could be speaking German, or actually, I guess on the West Coast we'd be speaking Japanese, right? I mean, the Japanese were planning on taking over the West Coast, the Germans taking the East Coast. So, anyways, rather important. So if you do not think that this was rather important, it's pretty interesting. And look at the bottom paragraph there on 169. So we had the invasion. It went okay. You know, we didn't just wipe them out first thing, but it went okay. But the bottom line was, look, 11 days after the invasion, they made the forecast for the second window that they could have gone. And if that happened, that day that they could have gone later was the biggest storm of the 20th century. And so if they had waited for the second window, it wouldn't have happened. We would have been speaking Japanese or German. So anyway, the bottom line is weather forecasting. You can sit there and say it's not a big deal, but it is truly an incredibly important business. And actually today, even today, with computers and a lot of the stuff we're going to be learning about, Embry-Riddle Aeronautical University, if you want to go there and be a weather major, you get money. They need you. You go for free to college if you want to be a weather scientist. It's pretty neat. Okay, so this lesson is interesting because it goes over the history of weather forecasting. You know, how did we get into it? Why did we get into it? And of course, how it's changed and the modern technology you guys take for granted and people like me have seen change in my lifetime. Bottom line is we were trying to figure out how to send air mail, government mail. And then think about it, guys. We're down in the southwest. We don't have much weather really down here. It's, 320 days of sunshine in Arizona. But in the northeast, like Washington, D.C. to Chicago, it is rain and bad weather a lot. A lot. Not every day, but half the days for sure. And so the bottom line was they were trying to get the government airmail carrying. They want to make sure get through the destinations. Yes?
Even when I went to DC over the summer, it was still pretty cold.
Pretty cold. Well, there you go. But
Summer.
and the summer is muggy. It's a lot of humidity.
Really humid.
Bottom line was in the 1920s, after World War I, they were trying to get airmail going. You can see a picture of the biplane there. And they were trying to also start aviation in a commercial sense, try to get people to pay to fly. And you wanted to make sure that you could actually get the passengers through to their destinations with the weather. The Army, of course, were the first aviators in America, and so the Army set up their weather service, and then it transferred to the NOAA's, the National Oceanographic and Air Administration, and they actually run our weather service today. So yes, we have a governmental weather service that gives us all the radars and operates all the predictions that we have. And it all, the Air Force and the Army is combined with it. The original forecasting had to do with 5-mile ranges from the airport, because that's all you really cared about. You tried to land, but I'm telling you, in the original days, you looked out the window, and if it was clouds, you wouldn't know what was on the other side of the clouds. Nowadays, we have satellites, right? We have satellites that actually measure the temperature and the dew point and the sky conditions, and different barometers would measure the pressure. We learned from the last lesson, if the pressure is going up, is that good or bad?
Good.
Good. High pressure is good. What if it's starting to go down?
Bad.
That's when you start seeing the wispy clouds up there. The weather goes down, you see the wispy clouds. In 24 hours, you have a front passage, things start to change. This is something that I've used a lot. It's called Automatic Surface Observing System, and I think we have one out here at Prescott Airport. It's an automatic system. They give you the automatic weather non-stop, 24 hours a day at all the destinations. It sends a little, I guess, microwave, I don't know, laser. It tells you whether or not you have any clouds, what's the altitude of the clouds, how much above the ground level it is, and it tells you the surface winds and the temperature of the airport you're landing in. That's all over the nation. Upper air, this is the hardest thing, is knowing what the actual temperature and the winds of the upper altitude is. You actually send out weather balloons. Even to this day, we send out weather balloons an awful lot to get the wind speed and the wind directions. Matter of fact, you wouldn't believe how many weather balloons are sent up every day. And where do they go?
Everywhere. 20% of them come back.
They probably are in, 75% of the Earth's surface in Earth is water. They probably have a lot of them in the lane. All right, radar, this is pretty much invented in my lifetime. The fact that they're saying that you can never predict the weather with 100% certainty, but the predictions of today's world are much more accurate farther out than when I was a kid. One great example is these radars. Let's talk about a Doppler radar. What is a Doppler radar? Yes, sir.
A Doppler radar helps you figure out the weather.
But what does it do?
Sends out radar waves to figure out where they're at.
Okay, so we send out a radar wave. How do we know where there's bad weather?
Because it can.
Because it'll rebound.
There you go. It bounces off, just like off that wall. So you send out something like a tennis ball, and it bounces back. You can measure how long it takes to get there, how fast the radio waves are going, so you know how far away it is. That can tell you that. We have radars at most of the large airports, certainly down here in Phoenix. And that then put together with the computers gives us the overall view of how bad our weather is. An interesting thing there on page 175, 2992. I'm not sure if it covers that. I don't think we cover that here. 2992. When we talk about the pressure, barometric pressure going down when it's bad weather and it goes up when it's good weather, exact example is what if we take off from New York and fly to England. Over the North Atlantic, the weather's usually bad, so the barometric pressure goes down. And so let's say you take off at New York and the barometric pressure in millibars is, say, 3002, and you fly and go through a low pressure system. Can I help you there, Cadet Smith?
Sorry. Yeah.
If we fly through a low pressure system, the pressure differential will go down. And even though you're flying with a certain pressure, and this determines your altitude, you fly through a low pressure system, you'll be at a different altitude than you should be. And there could be a mid-air collision, because the other plane takes off from a high pressure location and comes up to a different altitude. And even though you're flying same planes and you're looking at your altimeter at 1,000, example is above 18,000, 20,000 and 19,000 pressure, but you have different pressures that you go through, you could be at the same physical address and actually fly into each other at altitude. So yeah, you have mid-airs. So what they've done is be able to have 2992 as your standard above 18,000 feet. So that's kind of a trick question. There is no 18,000 feet that you ever fly in an airplane. You fly in something called flight levels. So when you take off and you go above 17,000 feet, you dial in, or the plane will change it automatically, 2992. And that's your standard altitude. At flight level 180, that means you've got 2992 in your airplane, and that's your altitude. So when you go up at high level with all the commercial planes, and they're flying long distances, everything is standard, just like it talks about on 175, that 2992 is the key to safety at altitude. So you never fly at 18,000 feet. You always fly at flight level 180. If you're at 19,000 feet, you dial in 2992, and that's flight level 190, or 195 would be 19,500 at 2992. Is that confusing enough?
Yeah.
The bottom line is above 18,000 feet, you always dial in 2992. And that way it doesn't matter whether you go from high pressure to low pressure to low pressure to high pressure. Everybody's standard up at those altitudes. In 1975, I think I have the picture here, 1975, they started launching satellites. Here's a question. You live on the East Coast, and you're a farmer. And all of a sudden, you notice the chickens start to roost, or the animals start to do weird things. Back in the early 1900s, or heck, after World War II, 1950s, what might be coming your way?
Aliens.
Aliens. Nope, not quite. What else? What might be coming your way?
The hippies.
Bad weather. Sir.
Bad weather, or something called a hurricane.
Whoa.
Okay? This is a hurricane that came into the East Coast that I was quite affected by, called Hurricane Hugo. So do you see how huge this could be? And imagine not having a satellite picture of this. South Carolina, where I'm from, is right in here. Okay, and it's getting ready to wipe out South Carolina. But all you're doing is a farmer, and all of a sudden you get the wispy clouds. And all of a sudden your animals start doing something different. They're feeling the decrease in pressure. Is a hurricane high or low pressure system?
Low.
Low, the ultimate low. The lowest pressure observed on Earth are in hurricanes. So the bottom line is, imagine if you're sitting there and all of a sudden you have some animals acting weird, and I mean in 2 days you have 200-mile-an-hour winds that you did not know were coming. So you can imagine that if you're a farmer, wouldn't it be pretty good to be able to see in advance that this devastation is coming your way? These pictures were actually, they came right through Charleston, South Carolina. I did not live there. All my cousins did. My cousins, actually, one of my cousins was newly married, had a house. The hurricane came through. The eye of the storm went right through the center of Charleston. And he went back and found his house with about 12 feet. No, couldn't have been that. He has 8-foot ceilings. 8 feet of water in it. He had to take an axe to the front door to drain his house. Completely covered with water. And you can see this devastation is actually right, I mean, I've been on this beach. This used to be a restaurant bar that I went to and ate. This is actually right beachfront in Charleston. So you can see the absolute devastation that a hurricane would come through. And it was a pretty amazing hurricane. My family was on parts of my cousins were on a beach called Folly Beach, and the bridge got wiped out to Sullivans Island. So imagine living on a beach and all of a sudden your bridge is taken away. So they were in a survival situation. They had to get everybody in the area that was still there and sleep in the last remaining buildings. Yes?
So if the hurricane goes straight through your house and you're in the eye of it, you run with it?
No. You sit there and hunker down and try not to die. We talked about this the other day. This was, 1989? It's a long time ago, 25 years ago. If the hurricane hits, which way is it the wind's blowing?
West.
West. East or west?
East to west.
Are they clockwise or counterclockwise? Counterclockwise, because it's an anticyclone. It is a low pressure system. High pressure systems go clockwise, which I know your generation does not know about clockwise. Haha, everything's digital. But the bottom line, here is the picture of the hurricane when it actually hit South Carolina, and you can see the most part of the anticyclone, the biggest flooding would be north of the eye. And this eye is actually hitting right on the harbor of Charleston. And I actually had another friend who did not evacuate and stayed in a concrete square hotel. And he actually wrote an article in the paper that said he saw the 200, it wasn't 200, like 180 mile an hour winds going one way. And then all of a sudden he looked up and saw the sky and saw the huge wall coming, ran right back in, and it's basically right now when it's coming through. Can you imagine? Look, it's large as a state. That's a big hurricane. That's big. And now we can see that. Has that always happened in America? Yeah, we never known this until they had the satellites to be able to see this stuff in my lifetime. It did not happen earlier. But
How far would it possibly be able to go inland?
It goes about 1,000 miles in. I mean, it goes all the way to Chicago. This affected Chicago. I mean, it goes in with a lot of strength, but over land it falls apart, but it's still a huge amount. I mean, 20 inches of rain. I mean, we're something that Arizona's never seen.
So if one hit Texas, it could get to us?
Well, it depends on which way it goes. I mean, it depends on the winds, right? Depends on how it goes. What affects Arizona usually is the ones that come up the Sea of Cortez, right? It comes through Rocky Point, and then we get some rain. We don't get 20 inches, but it's not unusual for the East Coast to do that. So you can see that, you know what, that's pretty good that we have these satellites that can do that. Matter of fact, on one of those, you even saw the NOAA symbol. That is the NOAA symbol right here that I'm circling. That they're the ones that actually do that's exactly what we're talking about, the actual satellite. And you see this is an infrared satellite, which is shows the precipitation. So the green is the least precipitation and the red is the heaviest precipitation. That's called flooding, okay? That's called flooding. And of course, if you're worried about rain and flooding, what if this hurricane on September 22nd came in at high tide?
Oh, there'd be a lot of
That would stink. So the most predictable thing about hurricanes, my whole life, and probably for your whole life, you can remember this, the most predictable thing about hurricanes is their unpredictability. You can get, I think it's going to come here. Yeah, we have a 50% chance of predicting where it's going to go, but it also can stop and then change 90 degrees and go in over here. There's just no predictability with them.
So it could have changed and gone to Florida?
Well, actually, this one did, because this was not supposed to hit Charleston. It was supposed to march up the coast, and it stopped and came straight in. And the people had about 6 hours notice. They had, a 4-lane interstate? They reversed all 4 lanes going away from the coast. You could not legally come to the coast because they were going to save people's lives, yes.
Is that the eye of the storm just to the right of your...
This is it right here, the eye of the storm, yep.
How is it not really in the direct center?
How is it what now?
It's not, it doesn't look like it's...
The hurricane goes this way with some motion, right? It's moving fast, 10 miles an hour, 15 miles an hour, okay? And again, the main precipitation usually lags the storm because it's going fast and it's pulling, if you will, because this is the low pressure, right? Remember, low pressure causes problems, and just it's anti-cyclone. Okay, the highest winds are in front of it, but the biggest surge, which floods everything, is after it, and usually on the top right for the anti-cyclone. Okay, you can see it. It was devastating. It was the biggest one to hit my family and I mean, look at the whole hurricane is larger than states. That's kind of crazy, isn't it? Kind of crazy. I know that my family, my mother and brother are right here in the center of South Carolina, 100 miles, like from here to Phoenix, away from the hurricane. They still had 100-mile winds after the hurricane was inland 2 hours. It still was over 100 miles an hour there. And they just wipe out whole forests. I mean, this is all, there's no desert there. These are all trees. So, imagine we're wiping out tens of thousands of acres of trees.
Would it take like a 50 tree and rip it up like it's nothing?
No, it would take 100,000 50-foot trees and rip it up like it was nothing. I mean, entire forest, tens of thousands of acres, look like matchsticks is what it was. It was very...
like a toothpick.
Yeah, exactly. You better believe it. Okay, so you can see from weather forecasting, it is great to have satellites. When this happens, we actually have these warnings that you guys now see on TV and on your cell phones, SIGMETs and AirMets. This has to do with aviation, and they come out and say, hey, bad weather's coming. What kind of bad weather do we have here in Arizona? Floods, dust storms. You know what? I'm glad you mentioned the dust storm. What is the fancy word for dust storms we have now? And that is really great. I am glad you mentioned the dust storm. When I first moved to Arizona, we would have a dust storm very much like this.
Beautiful.
And
I'd never heard of a dust storm. And somebody said, hey, dust storm's coming, or the radio would come, hey guys, dust storm's coming. So what? Well, guess what? I'd roll up my window of my car and I'd go inside, and all of a sudden this thing would show up, and I'd go out and everything is just devastated. Have we had a dust storm here really? It's really down in the valley, right? But have y'all been in one?
Yes.
I mean, it is amazing. And guess what? This is just 20 years ago. We could not predict them. We couldn't see them. We didn't have the small video cameras you guys have. We didn't have the helicopters. And you just all of a sudden say, oh, there it is. It's coming. And now you have amazing technology. Where's the one in Phoenix? There was a big one in Phoenix.
2 years ago.
You know, I mean, look, now you have, you know, the pictures out, the easy pictures of, no, is that one coming across Phoenix there?
It could be.
Yeah. So,
2 miles.
there you go. I mean, that looks like Phoenix. It's amazing that you can actually see them. It comes from Tucson, basically, right? They start up there in the desert between Tucson and Phoenix. So now we have some way of predicting that it's coming. And I'm telling you, oh my gosh, I couldn't believe it. Wiped out my car. I have a convertible. It was full of dust. I don't think I ever cleaned it out. It was ridiculous. Yes.
I was in Colorado, and they actually had a huge dust storm like that come through. We just walked inside and started playing NFL.
Well, it is rather difficult.
And there was farming equipment. There was farming equipment everywhere, covered with dust.
That is exactly the way it
And then it
is.
started raining, and everything was just mud. And we're like,
Well, you know, dust and mud, dust and rain does not do well. The other type of radars, you've probably seen these around at 160 of these, 3 or 4 in each state. These are called NexRad, and they basically are radars that read about storms, dust storms also, velocities, and they certainly take care of the prediction. Weather outlets, I told you that they have different types of 24/7 type of predictions. And I tell you what, let me tell you guys online, I have this on projected. Does everybody know what ADDS is? ADDS. This is it. This is where you sit there and go, hey, what's the weather in Prescott? Well, this is the connection electronically to the most updated information you can get nationwide. Okay, this is NOAA. And honestly, I look at this, I'll tell you a funny story, right down here in Florida. Whenever I wanted to go boating, I would come right here in Florida, and look, here I used to live in Panama City, and I would like to go out to these islands. Okay, so I would come just like this, and I go, okay, Susie, can we go out to the islands? Well, it looks like some bad weather there. Come over here on the left, and it talks about the motion of the reflectivity. So you can go right here, and you can see the weather coming. It's pretty cool. So therefore, you can see, all right, if I want to go right out here and go to these islands, does it make sense that I go with a huge front coming through?
no.
That's probably not the smartest thing I've ever done in my life. And so, and today, in that situation, today I would not go boating out there. Because look, and you can actually figure out with the time, these are usually 30-minute lags. So if I'm sitting right here, when's that weather going to be there? They'll be there in about an hour and a half. Yeah.
By the time you get there.
By the time, you better believe it. I got caught in a horrible, horrible storm there at one time. About killed us. But anyway, so it's just that easy. That's the fun part of the East Coast. The reality is, on the West Coast, we don't have any weather. And so if we come up here and go, what's our zip code? 86301. I think that'll work, right?
That's 1.
Okay, there's Prescott. Life looks good. It's good and great. And of course, if we really want to get crazy in Prescott, we can actually go and look at the radar. And of course, what does the radar every day in the West look like? Absolutely beautiful. There is not even a click there on the weather. So if we have weather, and if you want to know about rain, you click on there, and there's Prescott. Yes, ma'am.
We have 5 minutes left, sir.
All right, thank you. Don't let me go over. So this is there's nothing happened. That's a radar reflectivity of it. All righty, so this is the end of lesson 4, and we will be covering lesson 5 here. Thank you very much.